Hello, everyone. We are going to be talking about adding integers today. This is lesson 2 in chapter 3. It's on page 203. 203. So open your book to page 203. It's got that polar bear on it. And we'll talk about adding integers. Page 203. Got it? Plenty of time to have that done. All right. So let's talk about integers a little bit. We did our inquiry lab on Friday, and we were using all those little chips to show positive and negative numbers and kind of watch how they interact when we were adding them. But we sort of need to talk a little bit about integers, what integers are and what they aren't. So integers like 2 and -2, they're called opposites because they're the same distance from 0, but on opposite sides. So let's talk about these opposites. Here's a picture of one. Here is 0, right? Here is 3, and that is 1, 2, 3 steps from 0. Its absolute value is 3. Here is -3, 1, 2. It's also 3 steps from 0. So its absolute value would be 3 as well. So these are opposites because they're the exact same distance in the positive realm and in the negative realm from 0. Okay, so let's talk about some real world examples of opposites. I'll start you out. Like when we talk about temperature, we can have 3 degrees Fahrenheit, and we can also have -3 degrees Fahrenheit. And I want you to come up with a couple of examples, but be careful when you do, because just saying, oh, I was given 5 cookies and then they took 5 cookies away, that's not necessarily the opposite. The opposite would be the same distance from 0. So if you were given 5 cookies and then they took 10 cookies away and then you had -5 cookies, like you owed 5 cookies, those would be opposite, the positive 5 cookies and the -5 cookies, okay? So come up with some real world examples though, kind of like our temperature, where you might see some positive and negative numbers. Now you have a couple of things written down for our real world examples. Go over to our math examples. What are some math examples you have? -1 and 1, -15 and 15. You come up with a bunch of them. What are some examples? Add some examples of that. All right, so now that we have a picture for what these opposites are and real world examples and math examples, I wanted to talk to you about adding opposites. So 2 integers that are opposites, they're also called additive inverses. Say that with me, additive inverses. One more time, additive inverses. And the additive inverse property states that the sum of any number and its additive inverse is 0. So you don't need a math nerd to tell you that 2 plus -2 is 0 on a number line. We start at 0, we go up 2 in a positive direction, and we come back 2, and you land on 0. You don't need a math nerd to say the additive inverse property says that when you add the opposites, you know this. You know that if I give you 2 and then I take them away, that you're going to end on 0, right? With 0 cookies. So 2 plus -2 is 0. They cancel each other out. It's kind of like those 0 pairs when we were using the chips. Each one of those is an opposite. -1 and 1 are opposites, so they equal 0. And it's the same if you go to 2, 4, 5. Any of your examples, -15 plus 15, 0. Nothing's left. So think about this. If the temperature outside is -5, name the temperature that would make the sum of the two 0. What temperature would I add to -5 to make 0? Aha, I would add 5, because 5 plus the quantity -5, those are additive inverses, and the additive inverse property says that when we add them together, they're 0. Awesome. So let's go into the next page. Now, this is where you need to get your foldable out, and I know that you have been super responsible. You tucked that somewhere that is very safe, that comes to and from math with you every day. No, you may not go back to your locker to get it, because that needs to stay in your math stuff, and you need to bring it every day. So if you don't have it, bummer. I guess it's a tool you won't get to use. If you have it, great. Take it out and turn it to the part that says adding integers, because this is our first rule. We talked about it last time in our inquiry lab. You guys worked it out. When these signs are the same, you just go ahead and add their absolute values. And if they're both positive, the answer is positive. If they're both negative, your answer is negative. So for example, the absolute value of 7 is 7, the absolute value of 4 is 4. We add those up, it's 11. It's all positive. It's like having a big pile of positive chips and a big pile of positive chips and pushing them together. I mean, you've known how to do this since 2nd grade or earlier, right? You kind of have known how to do this as well. You just didn't know. -7, the absolute value is 7, plus the absolute value of 4. That's how far away it is from 0. Remember, is just 4. And 7 plus 4 is 11. But in this case, what sign are both of these? They're both the same sign and they're both negative. So they are happily negative. You have a pile of negative chips here. You have a pile of red negative chips here, and you squish them together. You just got a big pile of negative chips, okay? So let's see how that works. I like to look at these on number lines because it's just another visual model. And look, this number line's fun. It's up and down. What do you know? So you always start at 0 if you're going to be adding or subtracting things. -3 really means that we're going negative. So we're going down to -3. And if we're adding another -2, we're going to keep going in that direction. And we're going to end on what? -5. Because -3 and -2, the absolute values of those are 3 and 2. That equals 5. And then our signs are negative. So we have a -5. Wachow. Here's another one. -26 plus -17. We just add those things up to 43 and it stays negative because they're both negative. So I want you to do A and C, and I'm really only going to give you about 10 seconds to do these because they're very fast. You don't even need to pause the video. Go. All right, let's take a look. So -5 plus 7 is what? 12. And both of the signs are saying negative, so it's a -12. Over here, absolute value would be 14 plus 16, and that is 10, 20, 30. And they're both negative, so our answer is going to be -30. Yahoo! Okay, so that's the easy part. If the signs are the same, you just add them and you keep them the same. If the signs are different, it gets a little tricky. But you remember on Friday when we did these, I can't remember who it was in class that noticed, but someone in each class said, oh, it's just like we're subtracting them. Yeah. And then we have to figure out which sign is the winner. Which sign has an absolute value that's the highest, and that is the sign that gets to win. In other words, what chips are left over when we take away those 0 pairs. So if we're adding integers with different signs, we're subtracting their absolute values. Now, don't let my absolute value talk confuse you. Absolute value just means you're adding those numbers up, and then you're taking the sign that's the largest number of signs. But if I tell you to, well, it says positive if the positive integer's absolute value is this biggest, and negative if the negative integer's absolute value is the greatest. Now, that's important because -9 and 4 here, if I say, oh, which one's biggest, that's the sign, that's not really right because -9 is way smaller than 4. If I have 4 cookies or if I owe you 9 cookies, this is actually the bigger number, even though it doesn't look bigger. But if I look at their absolute value and I say 9 is the absolute value of -9, minus, I'm going to subtract 4, which is the absolute value of 4. That's going to give me 5. And now I look and say, which one has the biggest absolute value? Well, the 9 has the biggest absolute value. Boom. Then we're going to keep the negative. Because if you think about it, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 negative chips, right? And I've got 1, 2, 3, 4 positive chips, correct? Well, I can come in and start taking out my pairs, right? Here's a pair, here's a pair. We'll mark off these ones and these ones. And then what I have left is negative because there's more negatives than positives here that we're putting together in our pile, right? So the negatives are going to win. that has the most left over. So that's why our answer is going to be negative. Over here, it's the same kind of deal, but this time I've got positive chips here and negative chips on this side. So what's left when we subtract those is 5, and then I look back at my problem, the 9 is the one that has the best absolute value. It's got the most chips in the pile, and it's positive, so my answer is positive. The difference is the sign has changed. That's the only difference. The answer is the same number, 5, but one is negative and one is positive. So let's look at some examples of these very quickly. I like to look at number lines. This is fun. We start at 0, okay? And we've got a positive 5, which means we're going to go to 5 here, okay? And then we've got a negative 3, which means we're coming back 3. We're taking away those 3 pairs, and then we've got 2 left over. We're really just subtracting. 5 minus 3, that's 2. But which sign has the biggest absolute value? This one. It's positive. I've got positive chips left, so I'm just going to leave that at 2. And that's where we ended on our number line, was positive 2, correct? Let's look at number 4. This one is negative 3 plus 2. It looks a little different on our number line. For one, we're going backwards first, negative 3. And then we're going to add positive 2, so we're going to head towards 0 again. This time we end up with negative 1. That's because if I subtract these, my rule says minus. It gives me 1, but look, which one is bigger? The absolute value of 3 is bigger, and it has a negative sign, so that's going to be negative 1. So you really look at which number numerically is larger, which one is farther from 0, and that's going to be your sign. That's the most chips left. So I want you to do D and E. Again, I'm going to give you about 15 seconds because these are pretty quick. You're going to subtract first and then take whichever sign is the largest absolute value. Go. Nice. You guys are all over it. I'm going to subtract these. And of course, since 7 is the absolute value of 7 is a little bit larger than 6, I'm going to put that 7 first. Otherwise, I'm going to get some funky answers. So 7 minus 6 is 1. But look, 7 has the greatest absolute value. And look at its sign. It's negative. So my answer is negative 1. And if I did this with chips, which you really could use chips for these, and I'm okay with you using chips to goof around for a little bit, but we really need to move from chips into the more abstract, into using your rules, because chips works for things like this and maybe even this one, but guess what? We're gonna have problems like negative 97 plus 32, and I can give you 120 chips to figure out, and then it will take a long time to figure out what your answer is. So we need to get ourselves to the point where we're using our foldable, or we're, even better, we're memorizing that rule, and I'll have a song for you on Tuesday or Wednesday of this week about those rules. So for those musical friends. Okay, so on this one, I've got negative 15. Okay, I've got 19 minus 15 because I'm subtracting. That gives me 4. And then which sign is the largest absolute value? My 19. So I have more positive chips left over. So I've got just positive 4. All right. Let's look at a couple other examples. Remember when we talked about that additive inverse property where 7 plus negative 7 is 0? This is just a reminder of that. It's still true. And negative 8 plus 3, well, let's practice. It means 8 minus 3, which is 5. And then our negative sign is going to win. It's the winner. So it's negative 5. Well, let's put that together. See this problem here? We've got 2 plus negative 15 plus negative 2. But guess what? I see a positive 2 and a negative 2. What do I know about those? Well, when we add them together, we get 0. So I could literally just line them out right here and be left with my negative 15. Or I can do like they do, and I can group these 2's and the negative 2 together, get rid of that because it equals 0, and then I'm left with my negative 15. So those are fun. They look more complicated, but they're really not. So I just want you to do 2 down here. I want you to do F, and I want you to do H, and this is going to be the one that's a little bit more tricky, but I think you can handle it. I'm going to give you about 15 seconds. Go. All right, let's see how you did. I've got, my rule says I subtract them if the signs are different. So 12 minus 10, that gives me 2. But if I have to figure out the sign, I have to look up here. 12 is definitely the best absolute value, the largest. So my sign's going to be negative. That's the winner. Over here, I have 3 integers. But look, what do I know about these 2 integers? They cancel each other out because a -6 plus a +6, those are opposites. So it's pretty much saying 0 plus -14, and that just means -14. How'd you do? Well, I'm sure. There's just one more thing I need to show you. These are really cool little word problem dealies here. This one's talking about a roller coaster. So we can talk about negative and positive integers when we're doing different things with money, when we're writing roller coaster, distance really works really well, or when a temperature goes up and down, all those kind of things. So if a roller coaster starts at one point, at point A, it's going to go up 20 feet. Up is a nice positive word for you. So we've got 20 feet in a positive sense. Down 32 feet. Down would be negative. We're going more towards the ground. And then up 16, that's a positive. And then we're done. So we're going to write an addition sentence. This is key, an addition sentence, which means we have to have pluses in between all of our things. So it'd be really easy just to say 20 minus plus, but we have to do plus, 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 plus. So guess what? Adding a negative is the same as subtracting. That's kind of what that rule is saying. So here we go. We're going to have 20 feet plus what? Well, we have to do a -32. See how I'm writing this negative number in parentheses? My students say, why am I doing that? If I don't, it's going to be a little confusing because I'm going to have a plus and a minus together, and that's going to be funky. And so it's kind of partially to set it off so our brain sees it and we treat it separately from the plus, and this is the negative. Also, another reason that we don't, if we have something like this, 5 minus x and 5 minus x, or like 5 plus negative x looks funny, 5 plus negative x. These things are different. 5 minus x is different than 5 times negative x. And so a lot of times we use this parentheses because we get to start talking about order of operations, and we do parentheses type things first. So they become really important. So we need to use them as we go along, or else it's going to be confusing, and it's going to be confusing later. Well, now we have 16 feet up. I don't have to put parentheses in that because the plus just, it doesn't have a double weird thing. All right. And then, so we're going to answer it this way. 36 plus -32, which is just 36 minus 32 is 4. And then the positive wins out. So our answer is 4. Okay. So I'm not going to have you do an example of that one. What I'm going to have you do is just go straight to your homework, because I'm so confident that you're going to rock this out. So your homework today, okay, is number 1, 2, 3, number 7, 8, and 9. And then I want you to do number 10 and number 12 on the back of this page. So you've got your 1, 2, 3. I know a lot of you circle 7, 8, 9. Then go ahead and do number 10. And then come to the back here and do number 12. All right. Get to it.